This is the solution video for section 4.4, problem number 13. So in 11 through 13, for each function, use the given first and second derivatives and use a sign analysis to sketch the graph of the function. All right, so what we're going to need to do is we're going to need to set the first derivative equal to 0 and the second derivative equal to 0 to determine the critical numbers. Put those on a number line, do the sign analysis of the first derivative, sign analysis of the second derivative, and then match those up to figure out what the curve looks like. All right. So I actually gave you the first derivative here, but then also I gave you the kind of simplified version of the first derivative. And then I used that to find the second derivative. All right. So I'm going to set the first derivative equal to 0. So 0 equals 5x to the 2/3 plus 20/3 x to the negative 1/3. All right, so I'm going to set that equal to 0. Now, in order to do that, I'm going to factor. So I can factor out a 5, and then I have x to the 2/3 and x to the negative 1/3, so I'm going to factor out the lower power, x to the negative 1/3, which leaves me with what? Well, it would be x to the first, because negative 1/3 plus 1 gives you 2/3. All right, so I have x, and then I have plus. Now, I took out the 5, so if I took 5 out of there, I would have 4/3 remaining, and I took out the x to the negative 1/3, so that's easy enough. So I have 5x to the negative 1/3 equals 0, or x plus 4/3 equals 0. All right, so 5x to the negative 1/3, that is never equal to 0, right? So you should make that not equal 0, because this really means 5 over the cube root of x, which of course cannot equal 0. But if the denominator were 0, then we could say that x equals 0 makes f prime undefined. Now, look at the original function. The original function is defined at 0, right? And so what would that mean? That means that the function is defined. So there is a point there, but the first derivative is undefined. So there must be a vertical tangent, corner point, or a cusp. Okay? All right, now we set x plus 4/3 equal to 0, so I get x equals negative 4/3. All right, so that's easy. So 0 and 4/3, negative 4/3, are going to go on my number line. Then I'm going to set f double prime equal to 0. All right, so over here I set f double prime equal to 0. So I have 10/3 x to the negative 1/3 minus 20/9 x to the negative 4/3. All right, so now I'm going to factor out here. So I can factor out, well, I have 10/3 and 20/9, so I'm going to factor out a 10/3 x to the negative 4/3, right? Remember, factor out the lower power. All right, which means if I factored out x to the negative 4/3, I have x to the what remaining? Well, I factored out negative 4/3, so that means I have x to the first remaining, because negative 4/3 plus 1 is positive, or sorry, is negative 1/3. All right, then minus, I took out 10/3 from 29, so I have 2/3 remaining, right? Because 10/3 times 2/3 is 20/9. All right, and so now I'm going to set 10/3 x to the negative 4/3 equal to 0, or x minus 2/3 equals 0. Now, 10/3 x to the negative 4/3, that is never equal to 0, because it really means 10 over 3 times the third root of x to the fourth. Of course, that is not equal to 0, but once again, x equals 0 makes f double prime undefined. But we would have already known that because f prime was undefined. So if f prime is undefined, then f double prime has to be undefined. All right, and so then x equals 2/3. All right, so now I'm going to create my number line. All right, and on my number line, I'm going to put negative 4/3, 0, and positive 2/3. All right, so now I'm going to do f prime above the number line and f double prime below the number line. All right, so f prime. All right, its factors are 5x to the negative 1/3 and x plus 4/3. All right, so, all right, 2 rows on top here. All right. All right, so on the top row, I'm going to put a u above 0, and on this bottom row, I'm going to put a 0 above negative 4/3. So now I have those intervals. All right, so now pick a number to the left of 0. How about negative 1? 5 times negative 1 to the negative 1/3. So keep in mind, what does the negative 1/3 power mean? It means 5 over the cube root of x. So 5 over the cube root of negative 1 is negative, right? Remember, the cube root of negative 1 is negative 1. All right, number to the right, how about positive 1? All right, so now, positive 1. 5 over the cube root of positive 1 is positive. All right. Now, remember, we should we should put a separation at 2/3, even though the derivative wasn't 0 or undefined there, just because we're going to have these 4 intervals. All right. Next, all right, a number to the left of -4/3. How about -2? So -2 plus 4/3. So -6/3 plus 4/3 is negative. Number to the right, like 0. 0 plus 4/3 is positive. All right, so now that means first derivative is negative times a negative, which is positive. Negative times a positive, which is negative. Positive times a positive, which is positive. And positive times a positive, which is positive. So that's the first derivative. All right, so now second derivative, I'm going to put my two factors. I have 10/3 x to the -4/3, and then I have x minus 2/3. All right, so now I'm going to have 2 rows here, all right, for the second derivative. All right, so now I'm going to put a u below 0 here, and I'm going to put a 0 under 2/3. So I'm going to draw my separations, and I should do a separation at -4/3. All right, so now pick a number to the left of 0. All right, how about -1? 10/3 times -1 to the -4/3. Keep in mind, though, over here, okay, 10/3 x to the -4/3 means 10 over 3 times the third root of x to the fourth. So -1 to the fourth is positive. Cube root of a positive is positive times 3. So that is positive, right? All right, number to the right of 0. How about 1, positive 1? So the positive 1 to the fourth is positive 1. Cube root of positive 1 is positive 1 times 3. So I have 10/3. So that would be positive. So it's very important that you remember you have to bring that power with. All right, on the bottom row here, number to the left of 2/3, like 0. 0 minus 2/3 is negative. A number to the right, like 1. 1 minus 2/3 is positive. All right, so now let's go up here. Positive times a negative is negative. Positive times a negative is negative. Positive times a negative is negative. And a positive times positive is positive. All right, so now we're going to match up our first and second derivative so we can think about what the curve would look like. All right, so positive first derivative, negative second derivative. So positive first means increasing. Negative second means concave down. So something like that. All right, negative and negative. So negative first derivative means decreasing. Negative second derivative means concave down. So something like that. All right, next one, positive first derivative, negative second derivative. So increasing, concave down. All right, and then positive and positive would mean increasing and concave up. So something like that. All right, so now we're going to join them together at the appropriate values of x. And since we were given the original function, we can find an initial point. And so this one, well, usually 0 is the easiest. So f of 0 equals what? Well, 0 to the 2/3 is 0 times 3 times 0 plus 10. So that would be 0. So f of 0 is 0. So we're going to put a point at 0, 0. And then we're going to draw the graph accordingly. All right. So I put a point at 0, 0. All right. And then I'm going to go over to x equals 2/3. And then I'm going to go over here on the left to x equals -4/3. All right, so now I have this concave down but increasing curve over here. So I'm going to draw something like that here. So increasing, concave down. All right, then to go from -4/3 to 0, it's going to be decreasing and concave down. So something like that. All right, notice these two join together at a horizontal tangent. And you look up here, okay, they should join together at a horizontal tangent because the derivative was 0 there. All right, but now going from 0 to 2/3, it should be increasing and concave down. So increasing and concave down. So now you think about it, 0, those two do not join together in a smooth fashion. Should they? Well, look up here. The first derivative was undefined. And earlier we said there must be a corner point, cusp, or vertical tangent. So it is a fact that there is either a corner point or cusp. We could investigate more, but we don't really care as long as we understand that they should join together in that way. All right, and then at 2/3, we have this increasing concave down and this increasing concave up. And so then that means the concavity must change to up. So notice concave up here, concave down here. Now, how do they join together? Well, look up here. The derivative is not 0, so it should not level off and be a horizontal tangent. See how this levels off and is horizontal? This shouldn't. The slope there should still be some sort of a positive number. All right, and so that is the graph of problem number 13.